Alright, so today we're going to be doing 6.2, which is going to be operations with radicals. So, a radical expression can be simplified if any of these things are true. That basically just means that there's more that we need to do to simplify the radical. Important thing you need to know about dealing with these radicals is that you need to make sure that when you're multiplying them together, that they have the same index. That's not top, so that's the wrong one. This one's you. You can have a calculator, this calculator. Take one of those and then pick C. Okay. So the important thing you need to know is that when you're trying to multiply them together, they have to have the same index. And when you're trying to divide them, they also have to have the same index. So if they don't have the same index, that's when we have to convert them into fractional exponents. Additionally, you can only add them if they have the same radical base. So same type of root, same type of root and same thing underneath that root. Alright, so first one we're going to look at here is letter A. So for letter A, we're going to look at the variables and the radicals. So as you can see, the radicals are the exact same on this one, right? So because of that, we can just add those, or subtract in this case, those coefficients. So what's going to be 3 minus 2? 1. So your answer is going to be 1 radical 5x, which is just equal to the square root of 5x. Now before we get into some of these problems, I just want to put this out there. Algebra 2, prerequisite skills. I expect that you're able to reduce a radical. So if you were asking me a lot of questions about how did you get this radical reduced, how do you reduce the radical, I can answer them the best I can, but we would be here for 2 hours on this lesson if you don't know how to reduce radicals. So if you need help with reducing radicals, I can recommend some resources online for you. Just let me know. If you're still like at the end of this, like I don't know how to reduce a radical, I can help you guys out.
Can I write on this?
Yeah, that's for another test, so you don't need that. Sorry, it's just chaotic with all the makeups. So this one here, as you can see, they don't have the same radical base, and they don't have the same coefficient to the same power. So for that reason, all we can do is factor out a GCF. So we can take out a 2x, which will leave us with 3x radical 7 plus 2 radical 5. So see, I was able to take out a 2x out of those. All right. Next one here, as you can see, we have the same radical with the same index, right? So because of that, we can just combine the coefficients. So what is 12 minus 8? Good. So the answer is 4 third root of 7xy. So any questions about that? All right. So these ones here, some of these we have to simplify before we try to combine. So in this case, I'm going to try to rewrite these radicals in such a way that they simplify as much as possible. So I know that I can rewrite radical 12 as the product of radical 4 and radical 3. And I know that I can rewrite radical 75 as the product of radical 25 and radical 3. All minus 3x radical 3. So this became this, and this right here became this. Okay. So what is the square root of 4? Good. And then I'm just going to bring this down. What is the square root of 25? Good. Bring this one down, and minus 3x radical 3. Now we're just going to multiply everything out. So this becomes 4x radical 3. This becomes 5x radical 3. And then lastly, this is negative 3x radical 3. So now the goal is now you're going to notice that they all have the same base and variable to the same power. Does everybody see that? So now we can just deal with the coefficients. What is 4 plus 5? 9. What's 9 minus 3? So I end up with 6x radical 3. Like that. Does that make sense? Okay. Alright, this one here is a similar idea, but instead of regular square roots, we're trying to take cube roots. So we want to come up with perfect cubes. So I can rewrite 250, and sometimes this takes a little bit of time to figure out what they are. Obviously, I just know these ahead of time, but this will break up into the square root, or the third root, of 125 and 2. This one right here will break up into the third root of 27 and 2. And then this one will break up into the third root of 8 and 2. So if you were to multiply these back together, you would end up with their originals. But there's a reason I specifically picked the ones I picked, because they happen to be perfect cubes, okay? So what number can I multiply together 5 times that will give me 125? Good, 5. So the answer here is 5 third root 2 plus, what's the third root of 27? Good, 3 third root of 2 plus third root of 8, 2 third root 2. So now I can just add the coefficients.
Wait, I have a question.
Sure, go ahead.
Why is it plus this one?
You're right. I think you just caught my mistake. I was just about. Is that what you were talking about? Yeah, I accidentally put a plus sign there. It should have been a minus, so I apologize. So 5 plus 3, bless you. 5 plus 3 is 8 minus 2. So our answer is 6 third root 2. And that would be our final answer. Any questions about that? Okay. So, next one we're going to do is we're going to practice multiplying radical expressions together. There's a few different ways that these radical expressions can be presented. These are mixed radical expressions, so this is a monomial, but you're going to notice it has a regular number portion and a radical number portion, as does this one. So here's how that works. You're going to multiply the normal number part together first, which becomes negative 8. And then you're going to multiply what's under the root together as well and leave it under the root. Now, in some cases, you're going to be able to simplify what's under the root. However, 35 is what we call a coprime number. Does anyone know what that is? So coprime is the product of two primes, and there are different primes, so this doesn't simplify any more than the way it is right now. Okay. All right, so this one, can I put these under one root as they are? No, because they have different indexes. Very good. So here's what I'm thinking instead. I know that I can rewrite the third root of 6 as the third root of 3 times the third root of 2. Now you might be thinking, well, neither of those simplify, so why would you do that? Well, you're about to see why in a second. So, everybody see what I did there? Okay. Now from here, I'm going to try to convert these into fractional exponents. So what would this be as a fractional exponent? 1/3. This one would be 1/3, and the last one would be 1/2. Now here's the reason I did that. These now have the same base, these two, right? And when two things multiply together have the same base, what can I do with their exponents? Add them together. So because I now have something with the same base, I can add 1/3 plus 1/2, which if you find common denominators, do all that, you get 5/6. Okay? You can just trust me, I promise. So this is going to be 3 to the 1/3 times 2 to the 5/6. Now, can we leave our answer this way? No, because the original question asked us in the form of a radical. We have to go back to the form that the question was asked, and that's going to give us the third root of 3. Did somebody knock, or am I just... Oh, okay. Third root of 3 times, the 6th root of 2 to the 5th power, which you could try to simplify a little bit. Thank you. All right. Ow. This one's you, and you can take a scientific calculator. All right. So, yes.
Why didn't you add the 1/3 and the 5/6?
why didn't I add these two together, you mean? Because you can only do that when they have the same base. Does that make sense? Okay. Alright, so as for the next one, you'll notice that these have the same type of root, so I can actually just combine them under the root. So what's negative 4 times 2? Negative 8. So what I did here was there's actually a negative 1 in front of this one, so I just multiplied the 3 and the negative 1 to get the negative 3. And then I multiplied the inside of the root because they have the same index. So does anyone know what the third root of negative 8 is? Not regular 2, but negative 2. Because you can take roots of negative numbers if the index is odd. Okay, a lot of people don't know that. The only time you get an imaginary is when the index is even. Okay, so what's the product of negative 3 and negative 2? 6. Alright, moving on. Letter D. So you have a few different options on how to do these ones. You can combine them right away, or you can simplify first. You're going to get the same result either way if you do it correctly. So let's try doing it as two separate ones, and then this one we'll try combining it just to see both options. So this one I know I can rewrite as the square root of 4 times the square root of 3 times the square root of x to the 4th times the square root of y squared times the square root of 15 times the square root of x squared times the square root of y to the 3rd. So now I'm just going to simplify each piece. This becomes 2. This stays the way it is. What is the square root of x to the 4th? Good. What's the square root of y squared? Y. This doesn't simplify, so we just leave it as 15. This right here, x, and then this right here, this one's a little bit more tricky. Anyone know what this becomes?
Oh, y to y.
3 over 2.
You're close. Yeah. So it's actually going to become y radical y. And if you're wondering why that is, let me explain. So when you have the square root of something, that means you're taking it out in groupings of 2. So y to the 3rd is just y times y times y. So pairs get to leave the radical. So a pair of y's gets to leave, but that single y that doesn't pair up has to stay behind inside the radical. So that's the reason that simplifies the way it does. Okay? Alright, so at this point, what I like to do now is I identify everything outside of the square root. So you can do this with a highlighter or just underline, and you can do one like with squiggly, one with regular underline. And that's just going to be 2x cubed y squared. I forgot another y over here. And then you're going to multiply everything together that is underneath the root. So you're going to end up with 45y. Now here's the problem with doing it separately. What do you notice about the final result? It's 45, so we want to just verify. Can we break down 45 again? We can. So sometimes you're going to have to do it again. So this is going to be on the outside. And then you can break this down into the square root of 9 times the square root of 5y, which means another 3 gets to come out, right? So 3 times 2 is 6. So this is actually the final answer on this one. So sometimes it's just a little bit of a tedious process to get everything fully simplified. So any questions or clarification on that one before we move on? Everybody see where everything came from?
How do we know that 45 could go on?
How did I know I could break up the 45?
Yeah.
You can always break up anything you want. It's just a waste of your time to break up things that won't simplify. But I know that 45 has a factor that is a perfect square, which would be 9. So that's the reason I would spend time breaking it down, because it can simplify more. Yes?
So we're on like a test or something, you have to like completely get it down to simplify.
Yes, completely. So you would get like partial credit for only getting it part of the way. Okay. Especially on like a multiple choice too, it's always going to have the most simplified form. Alright, so on this one here, Same type of thing is gonna happen on this one. We're gonna have to break it up as much as possible for each one, and then we're gonna have to group it back together and break it up again.
We said we were gonna combine them first.
Oh, you guys wanna do that?
I would like to, yeah.
Alright.
Alright, it'll be fun.
Alright, so we'll go ahead and combine it first. So this one is gonna become 1,575 x to the 6th, y to the 7th. So now, there's a few different ways you can do this. You can do a factor tree on this one, or you can try to find the largest perfect square that goes into this number. Sometimes they can take time to figure that out. So I'm just gonna do a factor tree. So I know that this right here, at the very least, I know that it's gonna break up into the square root of 25 times the square root of 63. So I just tried some random numbers. Those kind of worked. And then as for the variable parts, I can put those in their own roots and deal with those in a minute. So we'll just take it one step at a time. So I know that the square root of 25 is, and can I further break down the 63
Yes.
into
7 and
9 and
7.
7? Good. So the 9 breaks down into a
3.
3. And now I can multiply these together, right? So I get 15. And now I can start, I know that there's going to be a radical 7 in my answer because this didn't break down anymore, right? So this right here is going to come out and be x to the
No,
3rd.
6. Oh.
And then it's y to the 7th. So how many y's get to come out? 3. And how many stay behind? 1. So if anybody's confused by that, I have another way I can explain it to you that might make a little more sense. So if you're really not good with like understanding that, here's another thing you can do. You're taking the square root, right? So what you can do is you can take your exponent and divide it by your index. How many times does 2 go into 7?
Twice.
3. 3 times 2 is 6. You subtract, you get what? 1. The remainder is the exponent on the inside of the radical. The result of the division is the exponent on the outside. Does that make more sense to anybody?
Wait, so you just divide by 2?
I divided by 2 specifically because of the index of the radical. So whatever the index is. Yeah, go ahead.
I have a question.
Could you, that like you don't really necessarily make all them fractions, just make it like x?
You can do the fraction thing, but however, the problem with the fraction thing is it doesn't work unless the index evenly divides into that power. Otherwise, you're going to end up with a remainder situation again. Because if you try to divide 7 by 2, you're going to end up with 3.5 as your exponent. You see what I'm saying? Yeah, Jack, did you have a question?
Where did you get the 7 from?
The 7 came from me multiplying these radicals together. So when you multiply like bases, you add those exponents.
Like,
That's why it's y to
That's
the
why you're
6th.
dividing by divide of 7.
Like base?
No, it's the power on the y. You understand where this came from?
Yeah,
Oh, okay,
the
okay.
big eyelash.
Okay.
Why is it 7
Like a
y?
guy with big eyelashes.
Why is it 7y?
Yeah.
Because you're multiplying by the 7.
The radical 7 came from this one. It just so happened that they incidentally were both 7.
Oh, okay.
Yeah, it was just coincidence. Alright, we still got a lot more to get through. Thanks to your friend the hurricane that put us behind. Okay, so sometimes you are going to have to multiply radical binomials together. So with a radical binomial, you're going to use FOIL. So first times first.
Can you do the box method?
You can sure do the box method if you'd like. Outer times outer. So this is what people mix up a lot. When you're trying to multiply a number times a mixed radical expression, you multiply the number by the number, and then you just keep the radical the way it is, okay? And then this one's going to be 10 radical 2. And then the last one, I have to multiply the outside numbers together and under the radicals together. So you should end up with this after your first set of multiplication. Verify that. Now what you're going to notice is these middle terms are like terms. So you can go ahead and add those together, and you're going to get 26 radical 2.
And then lastly, you're going to notice that you can change radical 4 into 2. Take the square root. So that's going to simplify to give you 20 plus 26 radical 2 plus 16. And then you can combine these like terms, which gives you 26 plus, or 36 plus 26 radical 2. There we go. That was a mouthful. Yes.
When you multiplied last by last, did you add the twos or did you multiply?
I multiplied them. Yeah, it's tricky because that could have been either way. With radicals, typically you're multiplying everything. Alright, so this is what we call a conjugate. Now, conjugates have a very important use in radical operations. They help us get rid of, when we have a radical in the denominator, a radical binomial in the denominator. So a conjugate is when you have two identical terms, almost identical, but the only difference between the two terms is that they have a different sign between them. Okay? So that's what defines a conjugate. So to do this problem, we're going to go ahead and multiply it like FOIL, just like we did on the last one. So first times first, outer times outer, inner times inner, and last times last. Now what you're going to notice is those middle terms are actually going to cancel each other out. That's actually the property of a conjugate, which means that's going to happen every single time that you multiply a conjugate by itself. So that means that if you are familiar with a conjugate, you understand what a conjugate is, you can actually skip that middle step of multiplying the outer and the inner and just do first and last. Okay? So my final answer is going to be 23. So do we have any questions about that before we move on? Okay. Next one. So, sometimes you're going to end up in a situation where you have a radical expression. These are both monomials divided by each other. So the first thing you always want to do is you want to rewrite this as a big fraction. Okay? So the reason we do this is because sometimes you can simplify things under that radical first before anything else. Now, something you have to be particularly careful about when you're doing this is you have to make sure that these have the same index when you do this. You see how they have the same index of 2? Okay. So unfortunately, nothing's going to happen with the 9 and the 2. They don't divide. But inside the radical, what is going to be radical, or x to the 5th divided by x to the 3rd? X squared. So you see how we were able to at least simplify the x's there. Now we can take the square root. What's the square root of the top going to be? 3x over radical 2. But you're not allowed to have a radical in the denominator. So here's how we deal with that. When it's just a radical monomial, what happens when I multiply a radical by itself? It turns into that number. So what we can actually do is we can multiply the top and the bottom by the radical of itself, which just becomes a 2 in the denominator, like that. So that's called rationalization. Okay, that's what the process is called, of getting the radical out of the denominator. There's multiple methods to do this based on what you're given. So for the next one, do we have the same index on both these radicals? Yes, so we can try to combine them into one big radical first to see if anything here will simplify. So in this case, fortunately, 162 divided by 3 does divide, and it becomes 54. And then how many times does y squared go into y to the 3rd, or y to the 5th? Well, I always give the answer away when I do that by accident. So yeah, it's y to the 3rd. So I know that I can rewrite 54 as the product of 27 and 2, right? And then we have radical y3. This becomes 3. This stays the way it is. And this one just becomes y, giving me the final answer of 3. This is like an index, by the way. I kind of wrote it to make it look like it's not, so I apologize for that. y third root of 2 is my final answer. Any questions? Alright, and then we have one last thing that we can try. And then I'll have you try the last one on your own. So, the difference between this problem is it's not just a single radical anymore. It's a radical binomial. So, here's where the conjugate comes in. What you're going to notice is when you multiply a conjugate by itself, the radical goes away. So, if we want to multiply this by the conjugate, how can I do so that will keep the balance in my fraction? Multiply the top by that as well. So on the top, we're going to use the distributive property. That's going to give me 3 radical 4x times 20x all over first minus last. Now, can we take the square root of 4? What is it?
2.
So this is going to become 2 times 3, which is 6 radical x. This is the plus sign. I apologize. So, what can I break up 20 into? What's the 4 square rooted? So it's 2 radical 5x all over 4. Is there one last thing I can do to simplify this? Yeah, I can take out a GCF out at the top. And then isn't the denominator 2 times 2? So don't these cancel out? And my final answer is 3 root x plus radical 5x all over 2. So yeah, these problems can be a little bit tedious. Just a little. What I want you guys to do right now, you can work with a partner or by yourself, is go ahead and try letter B, and then I'll put the answer up in a few seconds.
Wait, so you went from 4 to 2 times 2, and then for some reason the 2 got canceled out?
Yeah, so the reason it got canceled out is because on the top I also factored out a 2.
Yeah. Okay.
No, it's okay. I just want to make sure you see it. Alright, so go ahead and try letter B. Use the conjugate method. See if you can get it. Alright, so a few announcements. As you all know, you have an assignment to do over break due to the hurricane. Everybody knows that, right?
Yep.
6.3.